So this question is asking to find the function, looking at a function and finding a value and its domain and range. So the first thing it asks you is, given this f of x is x squared plus 1 over x squared plus 4x minus 12, what is f of 2? Well, f of 2 is just this thing, this expression evaluated for x equals 2. So we have 2 squared plus 1 on top. We'll have 2 squared plus 4 times 2 minus 12 on the bottom. And we calculate that out. On the top we'll have 5. On the bottom we have 4 plus 8 is 12 minus 12 is 0. Uh-oh, you cannot divide by 0. So this is really undefined. So f of 2 is undefined. And that immediately tells me for this particular problem that 2 is not in the domain of this function, because I can't evaluate it for 2. Well, how do I find the rest of the domain of this function, if there is anything else? So remember, we have a rational function. A rational function means something divided by something else. And so you're always looking for where there could be a problem with that something else in the denominator. Whatever makes the denominator 0 is not in my domain. So I see that I have a quadratic function below, and I can factor that. If I factor that, we get x here, and two numbers that give me 4 in the middle will be 6 and 2. I want a plus 4, so I'll have plus 6 minus 2. So plus 6 minus 2 gives me that 4x here. So looking at this, it tells me that x minus 2, if x minus 2 was 0, that means x was 2. So we see that's already a problem. So in other words, x can't be 2. And x plus 6, if we set that equal to 0, we would see x is equal to negative 6. Well, x can't be negative 6, because then this function won't be evaluated for that number. So those are my domain restrictions. This is my domain. Those two numbers cannot be in my domain. That's a negative way of saying it. But my domain is everything except these two numbers. In interval notation, we write that as negative infinity, and we're going all the way to negative 6 because that's the smaller number, but we won't include it. Then we say or union, and then we go from negative 6 to 2. So notice I used the parentheses around this negative 6 to not include it, and similarly around the 2 I'm not including it, and union with 2 to infinity. So that's the interval notation for writing this domain. So here we have a similar problem. We have g of x is the square root of x squared minus 9, and we want g of 4, and we want the domain and range of this function. So g of 4 is simply just plugging 4 into that function. So we get the square root of 4 squared minus 9. So plug in 4 for x. We get the 16 minus 9 is 7. So that's the square root of 7. So g of 4 is the square root of 7. Now what is the domain of and range of that function? So if we think of the domain of this function, we need whatever's under the root. So this is another one of those things where you have to look for. Whenever you have an even root of something, the problem is if that is negative, because if whatever's under the root is negative, I cannot square root negative numbers and get a real number. So we want to make sure whatever's in the root, which is x squared minus 9, has to be greater than or equal to 0. So what makes that greater than or equal to 0? So maybe I'll think about what makes it equal to 0, and noticing that negative 3 will make this 0, and so will 3. So now I think about, well, what if I plug in numbers around here? What happens? If I plug in a number less than negative 3, like negative 4, let's say negative 4, well, negative 4 squared is 16, because it becomes positive, minus 9 is positive. So yes, that all numbers less than negative 3 will work. In addition, if you think about greater than 3, that will work as well. So that's going to work too. But what about in between negative 3 and 3, like 0? If I plug in 0 into this expression here, I get negative 9. That's less than 0. So that's not going to work. So anything between negative 3 and 3 will not be in my domain. So what is my domain then? It's everything up to and including negative 3, from negative infinity, and then from 3 onwards. You can square root 0. The square root of 0 is 0. The only problem is if that was sitting in the denominator, then that would be different. So to write that, so we could say x is less than or equal to negative 3, or x is greater than 3, And in interval notation, that's negative infinity to negative 3 with a bracket now because we include it, union with bracket 3 to infinity. And that's my domain. Now the next question asks, what's the range? And so this is a little bit tricky, this one, but we have to think, well, this is always going to be positive because the square root is positive, so we're going to be larger than 0, but how far can we go? Well, x can actually be any numbers except for these numbers in between negative 3 and 3, and so that's going to actually go on infinitely, because I could have like infinity squared minus 9 is an infinite number. So we go on infinitely. So my range is actually from 0 to infinity for this problem. And graphically, if this were the xy plane, graphically you'd kind of see this graph going up here forever, like that. Alright, this question combines the last two what we did, and it's asking a combination question that if f is x squared plus 1 over x squared plus 4x minus 12, and g is x squared plus minus 9 square rooted of x squared minus 9, find fg of x. So fg of x means f times g. Fg of x is equal to just f times g. So I'm going to write f here, which is x squared plus 1 over x squared plus 4x minus 12, and then g is just the square root of x squared minus 9. There really isn't anything else you can do with this. You might put a parenthesis here, make that, but you don't have to multiply it out. There's nothing else we can do with this function, but that is fg of x. Now, the more important question actually is, what is its domain? So remember, the domain of f, when we had f, its domain was negative infinity to negative 6, and then union negative 6 to 2, and then union 2 to infinity. So if you remember that was f's, and then g's domain was negative infinity to negative 3 with a bracket, union 3 to infinity. So if you're having fg now, the domain of that function is the intersection of these two domains. And what that means is what they have in common. What do they have in common? So one way to visualize that is, let's put these domains in different colors. So we know we have a negative 6 where there's something happening, then a negative 3, there's something happening, then a 2, and then a 3. So I'm going to change colors, and let's make the color of f, let's make it this kind of red thing, and we'll make it thick. We'll make a thick pen here. So f says negative infinity to negative 6, right? So negative infinity to negative 6, you're going to have a hole here, you can't include it. And then negative 6 to 2, so we have a hole of 2, and then it goes on. So that's f. And g, let's do g a different color. If we do g like maybe a green, okay, so I'll put g on top of it. G says negative infinity to negative 3, so you go negative infinity to negative 3, and you could include it, and then from 3 to infinity. So from 3 to infinity, like that. So what do they have in common? Oops, that one disappeared. What do they have in common? So the thing we have to think about is, where do they overlap? And you could see, well, the green and red overlaps all the way to negative 3, but not here at negative 6. So we could say, okay, well, negative infinity, we want to go to negative 3, but we can't include negative 6, so we'll have to go to negative 6 and not include it, and union, and then go from negative 6 to negative 3 and bracket it, because we could include negative 3, and that is in the domain of f, that red. So negative 3 is included, and then we union that, and on the top side here we have to go any way the green is and the red. Well, this green and red overlap right here on this side, so we're going to go from 3 to infinity. So that's the domain of this function, which is the addition of those two functions, and it's the intersection of the domains of those two functions.